So let's start. We're going to start from just talking about enzymes. What is an enzyme? Remember that the last time we had a tutorial, we talked about proteins, right? We talked about proteins. And I said that the function of a protein is determined by its shape. I said that proteins have got different shapes. We find that another one have got a shape like this, another one have a shape like this, different types of shape. And those proteins, they have ability to recognize the molecules which they have to bind to based on their shape. I gave you an example of the key of a door, right? That not every key fits to a particular door. Each and every door have got a specific key, just like protein. So let us come and talk about enzymes. When people arrive, the neighbor tell them they know what they're supposed to do, right? The neighbor, you have to tell them. Okay, so enzymes are protein in nature. Enzymes are protein in nature. They are biological catalysts. They are biological catalysts. What do we mean? We mean that they fasten, they make the process, the chemical reaction to occur at a faster rate. That's what enzymes are. The proteins in nature, they make chemical reaction to be fast. They make chemical reaction to be fast. That's what enzymes are. But the question is, how do enzymes make chemical reaction to be fast? How do they do that? Let me give you an example of a chemical reaction, guys, which I'm talking about. Let's say I'm talking about water. In order for water to enter the cell, remember the last time I told you that water does not just enter the cell just like that. They have to use channels, right? And one channel which I mentioned, it was aquaporin. I said aquaporin is a channel which is used to shuffle water inside the cell. Remember the last time we talked about the cell, I can just draw. I said that the cell membrane is not like just a wall, but the cell membrane, it is made up of what? Two fatty acids and a phosphate group, right? And I said one is hydrophobic and one is hydrophilic. And I said that the hydrophilic part, it is afraid of water. It does not mix with water, right? Meaning water does not just get inside the cell. They have to use a specific channel. And those channels for shuffling water inside the cell, they are called aquaporin. In one of those two papers, there is somewhere where you need to explain aquaporin, right? Okay, although we'll get there, but we're just starting. How does enzyme make a chemical reaction to be fast? First thing, they lower the activation energy. They lower the activation energy. Lower activation energy. Lower activation energy. Activation energy, which is represented like EA, just like that. What is activation energy? Activation energy is the minimum amount of energy which is needed for a chemical reaction to occur. Look, this is a paper, right? Let's say I want to take this. I want this paper to melt because of this water. Né? When it is like this, it cannot melt, right? It needs my energy for me to take this water and put here, right? And my energy, I can refer to it as what? As activation energy. A chemical reaction cannot occur until a minimum amount of energy is put there. Then the chemical reaction occur. It's like when you are cooking. When you are cooking, what do? You put your food, your raw food, on a cooking plate, right? Which is hot, right? So that hotness is the what? what? Is the activation energy for cooking to occur. So activation energy is the minimum amount of energy which is needed for a chemical reaction to proceed. So let's take the minimum amount of energy which is needed for a chemical reaction to proceed. It is what? It is 120 kilojoules, right? We need 120 kilojoules. This 120 kilojoules, it's a lot of energy, guys. Then, what will a catalyst do? A catalyst is going to lower, is going to reduce this activation energy and make the activation energy to be 20 kilojoules. If the activation energy is 20 kilojoules, it means the reaction is going to be faster, right? Because we'll not have to wait a long time to reach that amount of energy for a chemical reaction to start. We'll always have that amount of energy because this time around the activation energy is lower. So the enzymes as biological catalysts, they do what? They lower the activation energy. When the activation energy is lowered, it means the chemical reaction is going to occur at a fast rate, right? Although I'm going to explain how does it work, what happens, and cycling. But those are the things which are important, which you need to know. Okay. Yeah, we're talking about biology, right? This is biology. Okay. So, there is this simple chemical reaction which shows how do enzyme lower activation energy. First thing, we start by reactants, right? Reactants. Then we're going to add an enzyme to the reactants, right? Then the enzyme is going to change those reactants to become the product. Because when we define an enzyme, we say it's a biological catalyst which cannot be consumed by the chemical reaction. It means even at the end, an enzyme is still going to be there. Because it's the one which fastens the chemical reaction. It's like when we start by enzyme, we must have product and an enzyme. An enzyme must not be consumed by the reaction. It must remain there. Understand? Okay. So I saw in your test whereby they were talking about a substance at which an enzyme acts upon. We call them substrate. Substrate. An enzyme acts upon substrate. Substrate. This word substrate means reactants. So it means an enzyme acts upon reactants. But in biology, we don't call it reactants. We call it substrate. So it means we're going to have a substrate. Then we're going to do what to the substrate? To add an enzyme. An enzyme will what? Will make the reaction to become fast. So it means the second thing which we're going to have enzyme substrate complex. We're going to have what we call enzyme substrate complex. What is an enzyme substrate complex? It's when the substrate, they are now combined with the enzyme. The enzyme is doing its work to change the substrate to become the product. Remember I said substrate means reactant, right? So we're going to start by the substrate plus an enzyme. Then we're going to have enzyme substrate complex. Enzyme substrate complex means the combination when the substrate and the enzyme are combined to become one thing, to form a product. Then at last we're going to have what? We're going to have a product. We're going to have a product. We're going to have a product. So, let's talk about this thing. Look, let's talk about general. They can ask you a question. How does an enzyme lower the activation energy? You don't just have to mention one thing like it is going to like how the enzymes fasten the chemical reaction. You don't have just to say one thing for 5 marks that it is going to reduce the activation energy. No, you have to explain further, right? Here is the first thing. Let's take this is an enzyme. This is an enzyme, right? In an enzyme, remember an enzyme is a protein, right? In an enzyme, there is a place which is called the active site. There's a place which is called the active site. And in this active site, an active site looks like a porch, like a platform where the substrate attaches. So it means the substrate does not attach anywhere. The substrate attached in the active site of an enzyme. Let's say this is an enzyme. It's going to have a shape like this, right? This portion, it is going to be called the active site. This is the substrate. The substrate is going to attach here. Then the enzyme is going to change shape. But I'm still coming there. The active site, right? The enzyme has got an active site. In the active site, that's where the substrate attached. Remember I said enzymes are protein, meaning that they are made out of certain chemical groups. On the R group, remember the R groups, right? We've got R groups which are ionic. We've got R groups which are they've got different bonds, right? So here we're talking about substrate. We're talking about living things, biological things, right? So what will happen when the substrate attached to the active site of an enzyme? The R group in the active site of an enzyme are going to interact with the substrate, right? Remember, these are chemicals, right? Chemical bonds are going to form different chemical bonds, right? So as they interact, it will cause the enzyme to have a strong grip to the substrate, which is called the induced fit. The induced fit. Induced fit. Fit. What is an induced fit? An induced fit is the state whereby the enzyme have a strong grip to the substrate. You understand what is causing the strong grip? The strong grip is caused by the interaction between a substrate and an enzyme, because an enzyme is a protein which have got R group, which have got different chemical bond. You understand? Let's take in the R group, we've got hydrogen. It means if the substrate, in the substrate, if there's oxygen, what's going to exist there? Hydrogen bond, right? You understand what I mean? So it means when a substrate attached to the active site of an enzyme, it is going to cause the enzyme to change shape because of the interaction of chemical bond there. You understand? To form an induced fit. So, what will happen after when the induced fit is formed? What will happen is that the chemical bond which are in the enzymes, they provide a suitable microenvironment for the substrate to be changed into a product. You understand? That's how this enzyme is making a chemical reaction to be fast. It means here in this pouch, there is a suitable environment for the substrate to be changed into a product fast. Do you understand what the enzyme does? The enzyme can act as a complementary strand to direct the substrate. That's how an enzyme fasten a chemical reaction. Are you understanding what an enzyme is doing? Do you see what an enzyme is doing? Guys, you don't see. Do you understand? You don't, eh? Which part don't you understand? Actually, you don't have to understand. You just have to listen and hear this part. It's not everything which needs to be understood. Okay, let me explain. Let me start. Although I'll be fast. Look, guys. Here we're talking about substrate and an enzyme. I said an enzyme is a what? An enzyme is a protein in nature, right? It fastens chemical reaction. So the question is, how does it do that? How does an enzyme make a chemical reaction to be fast? I said in an enzymes have got different shapes, right? So that they can fasten different reaction, right? It's not like it's one enzyme which make all the reaction to be fast. We'll have even a running stomach, because even a running stomach is caused by what? Enzyme making a chemical reaction to be fast in your stomach. You eat and then you go to the toilet. You understand? Same thing. So each and every enzyme have got a particular shape. It have got a particular shape. There's a place in an enzyme which is called the active site. In the active site, that's where the substrate attach. What is a substrate? A substrate is a reactant, right? It's what we are interested in to change into a product. That thing called the substrate attached in an active site of an enzyme. An enzyme is a protein. It has got the R group. Or it is made of different chemical reactions, guys. We know that a human being, it is a structure of different elements. We've got magnesium, we've got hydrogen, we've got different types, we've got copper, we've got iron, we've got different things. This structure, right, it is the combination of different elements. Do you agree? You agree, right? So, what is happening? Even this enzyme, it is a protein, it has got different what? Element, right? Remember, when we take two elements, we put them close to each other, they do what? They react, right? They can form bonds there, they can form ionic bonds. They can form what? Covalent. It's like you find that this part of an enzyme have got sodium, right? Then the substrate have got chlorine, right? When they come together, won't there be a formation of sodium chloride? It's an example. Side thing does not exist, right? It's an example that enzyme is made out of a different element, right? So what will happen when a substrate attached in an active site of an enzyme? The enzyme is going to change shape. It is going to have a strong grip to the substrate. Why is it changing a shape? This is because of the chemical bond which will be formed. You agree? Look, it has got the shape like this, and it has got hydrogen. Then I'm taking a substrate which has got oxygen. I put it here. Hydrogen and oxygen are going to what? To form a bond, right? That bond is going to change this shape. Do you agree? You understand? It's like when you take ice. Have you ever taken ice? You put your tongue here. It will stick. Do you know that? Sometimes it can be even painful to remove it. Do you know that? It's because of what? It means there are bonds which are being formed, right? Right? The same apply to the enzyme. It is going to change shape. So how does an enzyme fasten a chemical reaction? First thing, in this place called an active site, there is a suitable environment. There's a suitable environment for the reactant, the substrate, to be changed into a product. You understand? Meaning that this environment, it's the best environment for the substrate to be changed in a product. Do you understand? Because of that, it makes the chemical reaction to be fast. Another thing, the enzyme can act as a strand which can orientate. To orientate is to direct, right? The substrate to be converted into a product. You understand? That's what the enzymes does. It creates a suitable environment. It can act as a complementary strength to direct the substrate to be changed into a product. Did you understand, guys? It's like this. You see this is substrate, right? This is substrate. We want to change this to become something which is useful in our body, right? So what are we going to do? This is an enzyme, right? Look, we put it to the active side, right? Look, you see this, how it is? We put it to the active side. Look what the enzyme does. This is the product. Is it the same with the thing which I put here? This is the product, it's a different thing. That's how this thing of enzymes work. Did you see? That's how this thing of enzymes work. Did you understand this time? We're fine, Moses. Hey man, with the cap, are you fine? Yeah, you must talk to us, guys. Yeah, okay. Okay. Let's talk about enzyme inhibition. We talk about the enzyme inhibition. Look, enzymes are not always working, guys. Imagine enzymes are working always, all the time, even if they are not there to work. They need to be inhibited. To inhibit means to be stopped. They are no longer needed this time. It's like when you eat a lot of sugar, right? We need what? Enzymes to what? To break that sugar, right? But it can't break the sugar all day long. It must break after eating. Then it must stop. Meaning it must be inhibited. When we talk about inhibition, we're talking about that. So, there are two types of enzyme inhibition. Two types. There's what we call competitive inhibition and non-competitive inhibition. Competitive inhibition and non-competitive inhibition. Let us talk about competitive inhibition. In competitive inhibition, the inhibitor of an enzyme activity, inhibitor we are talking about, I can say informally, a stopper, the one which stops, right? Inhibitor, ne? Stopper, the one which stops, but don't go and write for stopper. There's no such thing in life science, right? Okay, the inhibitor, it have got the same shape as the substrate. It have got the same shape as the substrate. Then it competes to be admitted in the active site of an enzyme in order for it to stop the admission of more substrate, right? Understand? Okay, guys, this is the what? You see, there are two, right? This one is a substrate. Substrate is a reactant, right, which must be turned into product, right? Then this one is an inhibitor, right? They've got the what? The same shape, right? Let's say we admit the what? The inhibitor in the active site. It means the active site will remain like this, right? It will not admit, it will not take another substrate for a chemical reaction to be made fast, right? It means the inhibitor will stay here, right? That's how the enzyme is going to be stopped to work. Did you see? Did you see competitive inhibitor? It is called competitive inhibitor because the inhibitor and the substrate, they've got the same shape. They are competing to be attached here. Understand? Guys, I'm talking to you, the guy at the back. Do you understand? I mean you. Yeah, guys, talk to me. If you don't understand, tell me. I don't want to be talking alone here. Isn't it? You came here for us to talk to each other, right? Don't betray me. Okay, I assume you understood. It's competitive inhibitor. They are all competing to be admitted in the active site. They've got the same shape as the substrate. Fine. Going to non-competitive. Non-competitive inhibitor. We're still together, most. This one, this inhibitor, it is not competing to be admitted in the active site. It is not competing to be admitted in the active site. But it attached in another place away from the active site. When it attached to this place, it caused the enzyme to change shape. It caused the enzyme active site to change shape in a way it will not be able to admit any more substrate. Do you understand? Let's take this is an inhibitor. You see an inhibitor. This is an active site. Then the active site come and attach here. When the inhibitor, not the active site, the inhibitor come and attach here to an enzyme, right? Then the enzyme have a shape like this. Will it attach something here? No. So this is called non-competitive inhibitor. You see, the enzyme is like this. Then an inhibitor come and attach in another place away from the active site. When it attached, it caused an enzyme to become like this, to change shape. Will it admit more substrate? No. Are we winning? That's what competitive. Did you learn this thing or it's for the first time? For the first time. Okay. You get it, ne? Competitive and non-competitive inhibition. Okay. Okay. Let's talk about this one. Factors affecting enzyme. The enzyme functions. Factors affecting the enzyme functions. What are these factors? Remember I said enzymes are what? They are biological catalysts, right? They are protein in nature. But they can be affected, guys, by different factors. And these factors is temperature and pH. Temperature and pH. We are always talking about pH. What does pH stand for, guys? Is there someone who knows what does pH stand for? Do you know what does pH stand for? It stands for potential hydrogen, right? Potential hydrogen. It determines the acidity and how basic the environment is. So temperature and pH can affect the functions of enzyme. Let's say the temperature is high, right? Although we know that we need high temperature, right? The high temperature makes molecule to have high kinetic energy in order to collide effectively, right? We know that temperature does that, right? But when the temperature becomes even more higher, it causes the protein to what? To denature. To denature. They lose their shape, right? They lose their shape, they denature. Then, let's say it's an enzyme which is used to function in an environment which is acidic. When we take it to basic, will it function? No, it will also denature. It will also do what? Denature. So temperature and pH, they affect the function of enzymes. We find these things are coming. You must know them. Okay, we find with the factors affecting enzyme function, right? It's temperature and pH. Okay, let's talk about the Km value, what we call Michaelis-Menten equation. We call it Michaelis-Menten equation, right? Which is called the Km value. What is the Km value? What is the Km value? A Km value is the substrate concentration when the enzyme is functioning at half its maximum rate. Can I repeat? Yes. The Michaelis maintain equation state that when the substrate concentration when the enzyme is functioning at half its maximum rate. It's an equation, right? It's a mathematical equation. The Km value. Those who did physics, they did this thing of Km, right? Huh? The Km, man, we did Km, man, I remember. Kc. Oh, yeah, Kc, Km. But it's the same thing, right? It is derived from the same thing. It's driven from the same thing, which is Km. Km. The Km value, right, is Michaelis-Menten equation, which is 1/2 Vmax. This 1/2 Vmax is what? It's when the enzyme is functioning at half of its maximum rate. Max stand for maximum, V stand for enzyme, 1/2 stand for half. You don't have to know any mathematics, just know the definition, right? Michaelis-Menten constant is when the substrate concentration when the enzyme is functioning at half its maximum rate. We are together, right? The question is, what is the relationship between between what? I can say the relationship between the Km value and the substrate concentration. Yeah, you can say that. I think I saw a question talking about something like that, right? The relationship between the Km value and the substrate concentration. Okay, the Km value. When the Km value is low, it's like Kc, right? Remember, we used to talk about when the Kc value is high, it had a certain effect, right? So this time, when a Km value is low, it means that the enzyme binding strength is strong. When the Km value is low, the enzyme binding strength is strong. What does that mean? When the Km value is high, it means the enzyme binding strength is weak. But we have to explain what do we mean by weak and strong. Look, when the enzyme binding strength is strong, what does that mean to the substrate? What does that mean to the substrate? It means more substrate are going to be admitted, right? In the enzyme active site, right? And we're going to have fewer substrate. Do you agree? Look, what is the relationship between the Km value and substrate concentration? What is the relationship between Km value and substrate concentration? Here is the science. When the Km value is low, it means that the enzyme binding strength is strong. It means the enzyme during that time is active, right? It's active, it has got power, it is strong. So it means if the enzyme is active and is strong, it is going to do what? To admit a lot of substrate, right? So when the enzyme admits a lot of substrate, what is going to happen to the substrate concentration? It's going to go down, right? It is going to be low. So it means when the Km value is low, the substrate concentration is low. Do you see where it comes from? Guys, do you understand? Eh? Man, you with a cap, do you understand the one? Yeah? No. You must, guys, you must not be afraid to speak, no? You know, myself, when I did my first year, back in 2015 at Venda University. I was so afraid of speaking. I was even doubting my English. When you got there, and the course was was hard because of being afraid to ask questions, to interact, right? So don't be afraid, guys. Talk. Why human? Why just like you? Why useless? Nothing is special. Nothing is special about us. Look at me. I don't even have a bottle. I'm drinking water on this cold drink bottle. You see? So don't be afraid. Talk to me. If you don't understand, ask me. Talk to me until, even if you can talk in your own language. I hear a lot of languages. Get it, Musa. Let me explain again. Look, there's a situation where the Km value is called the Michaelis-Menten equation. It is mathematical, guys. It is, okay, Km value is equal to the concentration of what? Of products, right? Of products over concentration of reactants. The reason, we know those who do physics, they know that this corner bracket means concentration, right? The reason I'm not even writing this, I know some of you did not do physics, right? Therefore, we have got nothing to do with these things. That's why we're going straight. We're going straight to the matter. You understand? So, what I'm saying is, this formula, guys, this formula makes us to calculate the Km value. You understand? So, at the end, it's either we've got a Km value which is low, or we can have a Km value which is high. You understand? Isn't it we're calculating? Let's take the concentration of product is 0.5. The concentration of reactants it's 1, right? We're going to have a number here, right? Depending with what we're measuring with, it's either the Km value is high or the Km value is low. So I was explaining the science behind the Km value being low and high. When the Km value is low, it means an enzyme have got the strong binding strength. It have got that strong binding strength. It means the enzyme works at its best when the Km value is low. What is the work of an enzyme? Is to change substrate to become reactants, right? So it means when an enzyme is at its best, what's going to happen? It is going to change a lot of substrate into reactants, right? What is going to happen to the concentration of substrates? It's going to be reduced, right? Because there is something which is dealing with it. It is very strong, it is dealing with it, that thing. You understand? So the question may come with, what is the relationship between Km value and substrate concentration? You understand? So it means the substrate concentration is going to be low when the Km value is low, right? Because when the Km value is low, the enzyme binding strength is strong. And the work of an enzyme is to deal with this thing of substrate. So it means the enzyme, the enzyme, when the Km value is low, the enzyme is strong, right? So it means the enzyme is going to deal with this. And the opposite, right? When the Km value is high, the enzyme binding strength is weak. When it is weak, it means it will not admit or change a lot of substrate into product. It will just change few. What can we say about substrate concentration? It's going to be high. What together, Mus? We're winning. Isn't it? Okay. Last thing, right? There's what we call feedback inhibition. It's what we call feedback inhibition. Feedback inhibition. It's nothing, feedback inhibition. Feedback inhibition is when the product which is produced by a chemical reaction become an inhibitor. You understand? The product, it is becoming a what? An inhibitor. It is called feedback inhibition. It's like the reaction is going to make a lot of product. When the process is about to stop, that product is going to become an inhibitor. It is going to stop the enzyme from functioning. The what? The product. So this time we will not need competitive or non-competitive, but the product itself is going to become an inhibitor. It is called feedback inhibition. We're done with this section.